यार वेलकम बैक टू द क्लाइंबिंग स्ट्रेस प्रॉब्लम। सो आज हम लीड कोड की क्लाइंबिंग स्ट्रेस प्रॉब्लम को सॉल्व करेंगे एंड दिस इज द प्रॉब्लम ऑफ डायनामिक प्रोग्रामिंग। सो लेट्स सी व्हाट इट टेल्स इन द एल्गोरिथम that you are climbing a staircase. It takes in steps to reach the top. Each time you can either climb one step or two steps. In how many distinct ways you can climb to the top, and these are some example inputs and this is the constraints given. So that is the entire question that I have. The main question is in how many ways you can either climb to the top. That means कितने strategies में कितने number of ways में हम nth step तक approach करेंगे. So let's understand the problem in board. Okay, so this is the stair. Get this is the stair. So now what the problem tells that in how many ways you can climb to the top. That means in how many ways we can climb to the top. Now let's understand the problem. Here it tells you can either climb one or two steps. So we can either climb one step or two steps. So the number of ways we can climb is either one step at one time or two step at one time, like this. In case of 2, the output is 2. That means we can climb through 2 steps. So suppose we want to approach in this step from this stairs. So how many ways there are? Look, this is the last n minus 1th step. This is n minus 1th step. So the number of ways to reach here, this is 1, because there is only one step and we can approach, from n minus 1 to nth step. सिर्फ एक step के through हम पहुंच पाएंगे nth step में. And now notice for the second one, this is n minus 2th stairs from this counting n minus 2. So in how many ways we can climb from here? There is 2 ways. First, हमने directly यहाँ से यहाँ तक jump किया. That means we jump 2 steps at once. This is 2 steps at once. And the second one is that we can go like this. We jump from here to here and then we jump from here to here. That means we jump one by one. So there is 2 ways. We jump directly 2 steps and we jump 1 plus 1 step. So the number of steps we jumped here is 2. So to only 2 ways how we could approach. So the number of ways to reach step n is the combination of this step and the combination of this step, the 2 steps. So we can write that ways of n, we can write in terms of code that ways of n, that is equals to ways from n minus 1th step. That means how many ways it will take from these to n minus 1th step, and plus ways to reach from n minus 2th step. So this is the combination of steps we require to reach up to the nth step. Now try to understand. Here we'll be applying Fibonacci. If to reach this step, nth step, it takes n minus 1 and n minus 2. So for all the n minus 1, n minus 2, this Fibonacci series, if we run this bottom to top approach, it will automatically provide us all the solutions. That suppose now we are breaking it in more details. What the problem told that if we have one steps, if suppose there is one stairs, so it will only take one input. One step is there. We actually require one step to approach from here to here. So for that we can write if n equals to 1, when the value of n is equals to 1, return n or 1. We can return it 1. This is one case. The second case is, we know we have already it has already provided us values of n minus 1 and n minus 2. That means if we just try to ride one stairs from here to here, if we try it, we have only one way. So we will initialize like this: dp of 1 equals to 1, and we will be initializing the second one. And if we want to ride like this from here, one step, so there are 2 ways. We can ride like this, then we can ride like this. So 1 plus 1, we require 2 steps. There we require, it is taking 2 steps. And another strategy is that like this, and we directly climb from ground to here 2 steps at once, because we have only 2 possible combinations. It is also 1 step, so this is 1 plus 1 step. So here we have 2 ways. These are 2 ways. So if we want to write second stairs, we have this number of ways. That means dp of 2 equals to 2. and dp is nothing but an array that we initialize. So we can initialize like this: integer array dp equals to new integer n plus 1, n plus 1. So we have initialized. So that was our base case. This was our base case. That is our base case, and now these are the checking case. Now we initialize it and this, and now at the end, for finding all the steps one by one, because they follow the same condition, they follow the same rules, we just apply recursion here, and recursion will automatically provide us value for all the steps. For all the step, recursion will automatically provide value. So we'll generally apply just a recursion and it will provide us a value. So let's write the code. Okay, so first we'll be writing first we'll be writing the base case. So let's write the base case. If n equals to 1, that means there is only one stash left. So there is only one possible combination through what we can return the stash. So return 1 or we can return n, just if. Now second, we will be initializing an array as shown, integer dp that is equals to new integer n plus 1. Because we store here all the values starting from 0 to n, we store all those 0 to n in dp. That's why we initialize with n plus 1. Here we'll be storing the number of ways. Okay, now as we can see in the description, now if we see in the description that we have initialized for one stash, we have initialized dp of 1. For one step we have initialized dp of 1, and for second we have initialized dp of 2. So we'll be initializing those steps. Those are the one of the important step. So dp of 1, if there is only one step remaining, there is only one way to reach step 1. Now dp of 2, to write 2 steps, there are 2 ways to reach step 2. So this is a bottom up approach. Here we are applying a bottom up dynamic programming. Here we are applying. Okay, now we need to find for all the steps, and look what we have got in here. We have got from the nth step, from nth step if we see, we have got this general formula. So we will be applying this code line in the program. We have initialized all those. Now we'll be writing those steps, and now we'll be starting the program for I equals to 3. For integer I equals to 3, I less than equals to n, I plus plus. And here we will be storing the value dp of I, that is equals to dp of I minus 1 plus dp of I minus 2. So here it's storing the value, and at the end we'll be returning the dp of n. Return dp of n. Okay, so the program is completed. Now we'll be submitting it. So as we can see that we have beat 100% of users. Now notice this is the optimized, and now we'll be discussing the memory complexity of this algorithm. Okay, now if you see in the program, here we have initialized the n plus 1 array. That means what? That means when here we have utilized n plus 1 array, so what we did in the program, that we started running the program like this. For integer I equals to 3, I less than equals to n, I plus plus. And here we were just, this is top down approach. So dp of I, that is dp of 3, that is equals to dp of I minus 1 plus dp of I minus 2. So we applied this code line, and every time, do you know what it did? If we have 5 stairs, so it ran for that 3, 4, 5, and we have created memory for 0 to n. That means 1, 2, 3, 4, 5, 6. We have memory for 6, and entire value got stored here. So it filled actually the entire memory. It filled entire memory for everyone, and at the end it filled, if the n was 5, it filled value for 5 also. So starting from 0, it filled all the value up to 5. So this is, we are utilizing all the memory here. So in general, the time complexity here was big O of n, big O of n, and the memory complexity is also big of n. Memory complexity is also big of n. But in LeetCode, in optimization, our main goal is to optimize. Here we can reduce the memory complexity into big of 1, and to reduce, we just have to change a little line. Instead of creating that array, if we just use one variable, and we just swap those values, it will provide us the most optimized version. So let's look it. We will just initialize as all the values are, and we will swap. So let's see it in the program. So first, this is if n equals to 1, return n. So okay, now we'll be moving towards the most optimized version. So first, we will be keeping up to the base case. This is our base case that we must provide, the one case, base case. Now integer first, that is equals to 1. That means there are only one way to reach step 1. Integer second, that is equals to 2. And now we will be utilizing the most optimized version. So we will be calculating up to n for integer I equals to 3, I less than equals to n I plus plus, and it will run like this. Integer third, so we'll be storing that first one, as I saw in the Fibonacci that they are adding the previous two. So first and second, we now added and assign it. Now we'll be swapping the value. First will be assigned one, second will be assigned on first. Second, now second is on third, and this way they are swapped. And again, when for the next iteration third will come, it will automatically get the value of this first and second. And now the second contains the most optimized, second actually contains the answer this time. So we'll be returning the second. So simply return second, and now let's run and see if the program compiles. And we saw this compiles. There is no memory difference, but in long and large problem we'll get the memory difference. So that's done. We'll be meeting in the next video. We have understood this LeetCode stars problem. This is very simple. So meeting in the next video.